Good afternoon, ladies and gentlemen. Happy Friday. I trust everyone is safe and well. Welcome to today's Open Classroom, which is number 47. Today we welcome back Christopher Smith, who is going to be presenting a water module class. Please remember that all our past webinars can be found on our website on the FAQ page, which is found on the Services pull-down menu. As always, please feel free to use the text chat service on your GoToWebinar app to ask us any questions you may have during Chris's presentation. So, good afternoon, Chris. Please take it away.
Thanks, Charles, and welcome everybody to this webinar. Today we're going to be looking at troubleshooting with our water networks. We'll first look at boreholes and how to troubleshoot any sort of issues that you'll be having. We'll then be looking at times. Certain times of day will have different results in your water network, and we'll be showing you at all the different places to look at that. And then I'll be covering the geometry checks, ways to check your geometry of your network to ensure that everything is working correctly. Let's go ahead and start off with the boreholes. Quite often we have issues with boreholes coming through to the support center, or generally we can look at this more schematically and having supply on the one side and demand on the other side, and the two creating low pressures. In this example, we've got boreholes contributing to a network and we've got water removing from a network. So if you take a look at your hydrogeological report and you find out what the yields from all of your boreholes will be, then you will be able to know what your supply to the network will be. The data has already been entered in for all the boreholes, but we're getting some problems with our network if we try and run a single step analysis. We'll get some low pressures along our route. I'm going to go to results and I'm going to look at the boreholes. Now the sum of all the yields is about 99 liters per second. But on this side, we've got a demand of 166 liters per second, but that is going to be the average. If we look at the demand pattern, you'll see that it can go up to 3 times that amount during the course of the day. And in that case, you would need a reservoir somewhere along your network. So for this application, I'm going to look at, with the yield and the pumps and the pipes and all connected, what is the delivery liters per second that I end up with? So the first thing that we need to do is have a look at our nodes and make sure that the nodes are all set up. All the pump stations have been set up for the boreholes, so everything's been populated and the pumps have been chosen. I can now just quickly go and say data nodes. This is where sometimes issues come in. As you know, nodes can either be used for connectivity in the geometry or for contributing to the network or drawing off from the network of volumes of water. If the node is only going to be used for the geometry of the network and not for drawing off from the network or contributing to the network, then it has to be set to demand and it needs to be equal to 0. So I'm going to browse along and make sure everything has been set to preset demand and set to 0. Here you can see there's a preset pressure. I'm just going to change it over to preset demand, have it 0 and continue. Now, remember we spoke about the supply and the demand? Well, we can't have this connected to the network. There would need to be a reservoir between this demand so that during the night when there's pumping, it will fill up the reservoir and cater for that peak demand. So let's just make this 0 for now and continue to browse and press OK. And we can just zoom into this location over here. So I'm just going to go zoom window. And I want to then go and put a reservoir on this. So instead of doing a demand, I'm going to put a reservoir. So we'll go to graphical, draw reservoirs, and I'm just going to press J and enter. It's going to snap it. I say, okay, there's my reservoir. We can now run the analysis. So I'll go analyze, single step analysis. We can start that and we look at the messages again. So now we've got a borehole that's running out of range. Let's go to borehole number 6. I'm going to click on that item. I'm going to say show me, and it'll zoom to that location. I can then right click water operations, edit the borehole data. I can then go to the equipment. I see that the length is populated. I can go to select the pump, choose the average, search for a pump, shows me a pump. I can say adjust speed. This pump doesn't allow for that. And we can say select. I can press OK. I can then expand this and close it. Press ZA again and run a single step analysis again. Show the messages and there's no more warnings. Now we want to see if this network's is actually pumping up. So I'm gonna grab any pipes and go to water operations and look at the vertical alignment. It's very important to look at your display settings, and I'm going to have the current grade line switched on. The reason we call it current, in this example there's only one grade line because we did a single step analysis, but if there is time involved then you need to change the time over here. So here you can see we've got our grade line and eventually getting to the reservoir. Great, so we've resolved that issue. We can then close this project. Don't need to save it for now. During this borehole analysis, we were looking at using the single step analysis. But if you do a time simulation, you're going to have different results over the 24-hour period. Let's go ahead and look at how to deal with these different results based on time. I'm going to open up a project. Let's go File, Open, and I'm going to open up So here you can see we've got our nodes that are going to display the pressure, our velocities, and our flow rates will be in the pipes. You'll see that the results are not currently being shown. This is not due to analysis needing to be run, but for it to be displayed. If I go to water and I expand that and I go down to results, I can now choose which ones I'd like to do. There you can see you've got the single step analysis. If you click on that, you will have your average demands across your network. If you choose the time of day, you will see that you have different pressures and velocities and flow rates during the course of the day. You could also look at it in a graph. So if we click on the link and we go display pipe graph, you can see the flows during the course of the day, as well as the velocities, the head loss, and the gradient. One other way of displaying, for instance, the pressures, is if we go to our display settings, we go to the nodes, you can also show the maximum pressure in bar, and we can also show the min pressure in bar. So I'll just put there. We can now go and look at changing the times of day, and you'll notice that the max and the min remain the same because it's displaying the max over the 24-hour period and the min over the 24-hour period. Let's create a layout and look at the effects over time. So I'm just going to choose a smaller section. I'll quickly just define a pipe route from here to say here. I'll just call this demo. Great, so I'm going to just move this up over here and I'm going to go to Tools, Vertical Alignment. You can see the demo path is already been shown. You can probably just change the screen size to suit us a bit better. And now you can see as I move my mouse along this route, the crosshair will move to show me where about this is. Importantly is to look at your time of day. You can see that you've got different times of day will show different results. Let's put on our hydraulic grade line as well. And here you can see the grade line is showing, and we can do start animation to check what is happening during the course of the 24-hour period which we ran the analysis for. We can then close that, and we can go and plot this route. So I'm going to go and say plot generate. I'm going to choose the water long section. I'm going to make sure that I use the dynamically updates when the model changes. I'm making sure that I'm using the demo route. I'm going to use the vertical scale of 200 to ensure that I fit the hydraulic grade line in. I'm not going to auto scale for this demo because really we just need one drawing just to show you how it updates. Here you can see I've got my vertical alignment as well as my hydraulic grade line along the top here. If we zoom in over here and we change the times of day, it will not update until you go to Force Dynamic Regenerate. There you'll see your items will update. Great, let's close this project. I'd now like to look at the geometry checks within the water module. This will ensure that our connectivity of our pipes is 100%. In the water mode, if you go to Tools, check Geometry, you'll see that there is duplicate nodes, start, duplicate pipes, near, internal diameters, checking the connections and checking crossing pipes to ensure that you've inserted a crossing T. If we go and look at, for instance, duplicate nodes, it'll bring up where there's a duplicate node at a certain location. We can select that item, say show, it'll bring it to us. We can then choose which one to delete. So if I go and delete the second one, there shouldn't be any issues left. Let's quickly go to close and rerun that checker. There's no more errors to be found. We can also go to check our internal diameters. You'll notice that I've got some pipes here that have got some issues. Let's choose this one for instance and say show. We can also choose to edit it. You'll see your internal diameter looking correct, but however, if you click on the down arrow, you'll see that there isn't a 450 available. So this is flagging that perhaps you've changed the material or the pipe class to a category that doesn't have that pipe diameter. You'd now need to choose a diameter that would suit. So if we press OK, it will then ask us, do we want to move the existing alignment vertically or generate a default alignment or do nothing? That is up to you to decide what you would like to do. You would need to go through all of these to ensure that your pipes are correctly matching the catalogs available to them. Let's zoom out again and go to our geometry check and go to check cross pipes. And here it's found a crossed pipe. You can see the two pipes are crossing. We can click on connect and it'll insert a node and cross the pipes for us, putting a crossing T in. Great, that's all we have time for today. I hope that this was helpful for troubleshooting with your water. Thank you very much. Have a great day further. Back to you, Charles.
Thank you, Chris. That was great. And thank you to all who attended today. If you would like any further information with regards to Civil Designer's water module, please use the email address listed on your screens right now or visit our website. Please remember next week we're going to be consolidating our 4 weekly classes into one compact 15-minute class every Thursday at 2 o'clock, where we will be covering different modules each week. On Monday, we'll release an agenda of Thursday's class, so if you don't wish to view all the modules, you will know when to log in. So, see you all next week Thursday at the same time, same place, using the same link. Have a great afternoon, weekend, and goodbye for now.